chose the Tonlé River as a study site for automated acoustic monitoring for a number of reasons. First, it is part of the Mekong River system that supplies over 60 million people with major sources of protein and micronutrients. For fisheries management, there is no current real-time monitoring that enables adaptive management, and a set of recent observations of reduced commercial catches, reduced species diversity, and shorter fish legs were all interpreted as flags that real-time monitoring would benefit the resource management of the system. The SPAMS, or a solar-powered autonomous acoustic monitoring system, was an integration of several technologies that enabled us to have real-time monitoring. It combined a solar panel and controller with a 200 kilohertz echo sounder, a large marine battery, and a Raspberry Pi that was used as a scheduler for data acquisition and transmission. The data we acquired really confirmed the strong relationship between diel and lunar cycles with fish density throughout the seasonal migration. We can use this relationship now to shift fishing effort during full moon peak migration periods to increase fish escapement, and at the same time reduce fishing effort, which should increase profitability to commercial fishers. We were fortunate to use some of the Internet of Things technology, where the Internet of Things is trying to connect every electronic device and make it available for use and monitoring. How we applied it is initially there were a couple of challenges. Both our field sites lacked grid-paced power and cabled internet access, yet we wanted near real-time data delivery. So this combination of solar power, local wireless network access, and these communication protocols from the Internet of Things enabled us to acquire data and send it to an AWS server in Singapore. We were then able to download the files and automate the data processing and visualization back in Seattle. This technology and approach is really not restricted to the Tonlé River, as it can be applied to any site in the world. As long as you can provide power and gain access to the internet, then you're good to go. We believe that this system can really be applied to better fisheries management and expand the applications. The real-time data flow provides flexibility to manage commercially and ecologically important species. The automated data and data processing can then be visualized for both managers and the public in near real time. So the use of metrics or indicators combined with ecologically important or managerially important thresholds can be set to send warnings or even activate mitigation measures when changes in important variables. As an example, for our system, say a percentage of the downstream migration occurs, and we could use that as a trigger to actually close or reduce fishing effort. Looking ahead, we see this as a very scalable system. We can install SPAMS units throughout the Mekong Basin and have all data flow into a central processing location. So a network of monitoring stations would enable local or regional management of living resources given dynamic or changing environmental conditions. As an example, is it a normally dry or wet year? And that may differ depending on where you are. Given these ongoing environmental changes associated with climate and or anthropogenic development, monitoring data can be used to establish baselines, quantify variability, and characterize longer-term trends in environment and resources of interest. But it's really important for the success of the system. A sustained program is going to need capital investment in equipment, training in hardware, software, data processing, and a concurrent education program to develop local experts that can maintain and use the system properly.